Greetings, Earthlings. Well, today we're going to try this ROSCO computer kit. I got the USB to TTL serial converter cable. I think I got that on Amazon. I forget. Has a connector on it which matches up with the pins on the board, so that's nice. And I've set it to take power from the USB cable. I also got, while I was at it, some little SD card interfaces, and try those at some point, but not right now. But those should wire in here, I guess. SD card right there. Before we get to that, though, before we plug it in, I wanted to go back and review a couple of things because I've spent more time looking at the schematics. And as I said in the last video, I have some issues with the way the schematics were done. And of course, the whole point of this thing, of buying this, was to save me time. But I'm not sure it's going to, because I've taken to redrawing the schematics to get them to where I like them, and then I'll send those to the ROSCO people, and they can do whatever they choose with them. But a couple of little things. You have some signals which are active low, and they're indicated by a little bubble on the schematic there, on the chip. Now, what you normally do then is the signal name has a bar over the top of it. Okay. Well, for example, up here I said beer, right? B-E-R-R. You should have a bar over it like that, if you can even read that. There is, of course, the issue of just everything is like, it's all sort of drawn as separate standalone things. You don't see how anything connects. I want to see, get a sense of how the thing works, and so, I'll show you this is the CPU page, but I'll show you the at least working version of that I have, and you can see that things flow from inputs on the left, outputs on the right for the most part, and it's just instead of just having named network nodes, you can actually see like where the resistors are connected, and the pull-up resistors and stuff like that. I had real problems with this page, and I haven't even touched this in my work. But so this is the dual UART chip, and instead of grouping, so there's data lines, there's inputs, there's outputs, there's power and ground. Instead of sort of like grouping them logically, they just went pin 1 through 22, pin 23 to 44. Just like it would be on the chip. That doesn't make any sense to me. There are these two LEDs, which I guess are these two here. I don't know what they're for. They don't seem to be documented anywhere. These two, this one says run, this one says reset. Okay, I get that. There's two like general purpose output pins on this dual UART chip, which are driving these LEDs, but again, I don't know what they're for. Here's another thing, I'm going to assume like 1.7 volt drop when the LED is on. And we're at 5 volts up here, so there's 330 ohm resistor. That says that, assuming that this goes clear to ground, which it doesn't go fully to zero, but that's okay. For our purposes, it's close enough. These are running at like 10 milliamps. Okay? But if you look at the data sheet, which, I mean, doesn't say it explicitly, but basically these outputs are rated at, I think it's like 2.4 milliamps. So they're overdriving that. These resistors should be higher. The LEDs will light up at 2 milliamps. And so the resistors ought to be such that it's 2 milliamps. On the other ones, the power, well, the run light and the reset, I think those are okay because they're coming off these GAL chips, and the GAL outputs are rated at 16 milliamps. But even so, there's no reason to run them at 10, unless you want them to be as bright as they can be or something. In which case you could get brighter ones, higher efficient ones, or higher efficiency, or what have you. Consistency. There's a consistency issue. Where was that? Because we had those bubbles, right? Here we go. The ROMs. Okay. Instead of having the little circles, the little bubbles there, they have these like triangle things. Okay, like, let's be consistent, guys. If you're using bubbles, use bubbles. If you're using this is a newer form, and I think it has a slightly different meaning, but for the purposes of this, it means exactly the same thing. That's an inverted signal. So given that this is supposed to be old school, the bubbles are the old school solution, so it ought to be bubbles. That's my thought. Okay. Like I said, I'll get that done and make those available, and they can ignore me or whatever. It doesn't matter to me. But at least I'll have a copy that kind of makes sense to me. Okay, so we've got this. I've got that big giant chip in there. There's a trick to that, which I'm not going to show you to getting that installed. It involves bending the leads so they're straight, so they line up with the socket properly before you try to insert it. Okay. Here's a Windows XP laptop. Windows XP? Why, that's pretty old school. Yeah, that's the whole point, right? I don't know. In the documentation, they pretty much ignore Windows. They say they say Linux or Apple, and for Windows they recommend, I don't know, running some virtual machine or something silly. Well, I'm going to try it with Windows XP. So we'll let this boot up. Okay, and what I'm running here is Hyperterminal, and I have it already set up. Yes, I did try this before. I did this video to make sure that you might see something useful in this video. So it's using actually I think it's COM12, but here's the data rate, 115,200 bits per second, 8N1, okay. And well, so it should be getting the power. And I don't know if you can see, yeah, look, it's blinking. The mystery lights, the mystery red light is on, the mystery green light is blinking, okay. Whatever that means. But it's powered up. But if I press reset here, there it is, and it goes straight into Kermit. So, which is not what I was expecting. I was expecting to go into like a debugger or something, which would let me examine memory and things like that. So that explains, oh yeah, well that explains, I guess, why they don't have a settable baud rate. Going back to the schematics, yes, let's go back there. Because you can see right here, IP4, IP5. Maybe you can, maybe you can't. I don't know. IP4, IP5. Those are inputs, general purpose, input signals. They're not connected. Well, that's a CMOS chip. It's really not a good idea to leave CMOS inputs not connected. What I think I would have done there is run that out to like some jumpers and use that to set the data rate for the system console, system serial port. There's two serial ports, obviously, because it's a dual UART. But I would have had a selectable data rate on the system one, and then of course, that was assuming that it was going to go into a debugger. But even so, with this, if I'm going really old school, I don't have a USB port, but I have a serial port to some other computer. It might be a PDP-11, or whatever. And so I want data rates of like 9600, 19.2. Of course, 115.2 for the case where you're running this. And then I'd throw 300 baud in there so that you could connect it to a printing terminal. If you had different firmware that that didn't go straight into Kermit. Anyway, Kermit. Oh, what is that? Kermit. Well, Hyperterminal does Kermit, so I can send a file, and they provide some sample files, and I have saved them. So protocol Kermit, and let's do memcheck. Okay. And it's sending it. Okay, and it looks like it's running. How exciting. Okay, and that took a while, but you can see that it found a megabyte of RAM, which is what it has. It found the 512 KB of ROM, or flash memory. So there's the RAM, there's the flash, and then the I/O space is 256K in there. Try and get that. Oh, yeah, there we go. Okay. Press a key. Okay. We're back into Kermit. So what else do we have? We have... So actually that shows a lot working, right? Basically the thing works because we were... Let's do this one as a speed test. Because we're able to load code into it through Kermit, and we're able to run those programs, and they seem to run okay. This is a performance test. Now, I think the PDP-1173 has a little under 1,000 dry stones. This is 2380, so this is like twice as fast as a PDP-1173. That's cool. It's back in Kermit. Okay. Well, what else we got? We had there's a basic interpreter that comes with it. So let me find that. Where's EH basic? Okay. And that's only 17K. So it wouldn't be horrible to load that over a 9600 baud line. Okay. This is basic. Let's try all caps. Okay. What if I say run? No, it should have given me an error because there's no program. 10. Print. Here we go. Hello world. 20 for I equals 1 to 10. 30. Print. Print. I wonder, well, let's try that. Hello again. See if it takes that. Ooh, that was weird. 40 next I. 50 end. Let's do a list. Huh! I think there's a syntax error in 30. Let's see what happens. A syntax error in line 30. How about that? 30. Print. Hello again. Okay. Run. Okay. Hello world. Hello again. Hello again. Hello again. Okay. So that works. I don't know all the commands for this basic. Will it tell me how much memory is available or anything? Memory. I don't know. Like I said, I don't know. So I can list. I said list. I can new. I can list. That's all pretty standard basic stuff. Yeah. Okay. Fine. Basic works. Quit. Exit. Buy. End. Oh, brilliant. Well, I don't know how to get out of basic except to press the reset button. Okay, and we're back in Kermit. Okay. What else we got? Adventure. Oh, I remember this game vaguely. 14K. Yeah, so that's not horrible. Your 3-year-old grandson has gone missing his last seen in the direction of the abandoned farm. It's a dangerous place to play. You have to find him before he gets hurt, and it will be getting dark soon. Okay, help. Okay, look. Okay. Take. Key. Okay, go north. Look. Take bottle. Okay. Yeah. To play this game properly, you've got to draw out a map. You need a pad of paper or a whiteboard or something. So I'm not gonna keep going. But anyway, it does that. Are you sure you want to quit? Yes. Okay. No, I don't want to play again. Let's go back to Kermit. Okay. So anyway, that all seems to work. Okay, so I have replaced those resistors, the 330 ohm resistors, current limiting resistors for the LEDs, with 1.5K, which is what I had, which will limit the current to about 2 milliamps. And as you can see, the LEDs still light up, and they're still, giving a good enough indication. One other thing that I wanted to point out before we move on is that the bypass capacitors, these little ceramic chubbies here, the schematic calls for 100 nanofarads there. Now, I am old school, and there's no such thing as nanofarads if you're old school. There were microfarads and Mickey Mikes, or picofarads. All right, moving on. So it works. Future plans, like I said, we'll draw up the schematics. Then what I want to do is, as I mentioned in the first video, do a high-res monochrome graphics card, 800 by 600. I'm calling high-res because for the era it was. I actually sort of drew up kind of what it would look like here. Why 800 by 600? Well, because that will fit in 32K words of RAM. So some dual port RAM, a 7220, which is like my favorite CRT driver chip, then shift register, pixel data, and then driving the VGA. And it generates the sync signals as well. It looks simple, but it'll take some work. Okay. Now, having said all that, we do have a channel update here, and that is that this is likely the last video that I'm going to release on this channel. And the reason for that is that I'm going to be joining SAG-AFTRA. You may have seen recently that they were on strike. Well, just before they went on strike, I became eligible to join. And so I will be joining, and so then anything that I do, whether it's just my voice or my likeness or whatever, including on YouTube, needs to fall under a SAG-AFTRA contract. And I guess there are, ultra low budget deferred compensation SAG-AFTRA contracts, which I could look into for this channel, because this channel is not monetized. Actually, that's pretty much intentional. It doesn't have enough subscribers to be monetized, because I've never promoted it or anything. Nonetheless, people have discovered it, and so, as of now, there's 536 or something, 537 subscribers. But you need 1,000 to be monetized. But even if it's not monetized, SAG-AFTRA still, it would still need a SAG-AFTRA agreement. That's too much for me to think about looking into in the immediate future. So it's possible that somewhere down the line, I'll figure that out and, may bring it back. But for the time being, expect this to be the last one.